So let's talk about real quick how to do this in Stata, right? So we've got our Stata loaded up. I want to point out a couple of things. You can obviously pull in your own data files if you'd like to, and kind of do your own statistical analyses. But Stata comes with a number of what we call system data files, or data files that are publicly useful or perhaps have been created by Stata to use in the Stata environment so that you don't have to download and import something. And you can always use these. You can see a list of them also, but you can always use these via the sysuse command. So for example, we're going to use this auto data set, right? Because we sort of implemented a couple. There's a whole bunch of them that are out there that we can utilize for Stata. If we're going to do that, we're going to use sysuse and then auto.dta, right? So this tells Stata that we want to use the auto.dta in the system files. Now, what you'll see, those who are familiar with Stata, this is our results window. This is where all of our output will be. Here's our command interface. Sometimes you'll have this depending on the wide, how you sort of set up your Stata. Sometimes it's over here if you've not seen a history, but my history is over here on the left-hand side. And then we have a number of variables. And we can see in here, based on these variables, we've got a make and model, a price, mileage, et cetera, all of this information about this. So we're going to utilize this data set to sort of run a simple linear regression to start with. And when I mean simple linear regression in the terminology within there, it is simply that we have one independent variable and one dependent variable. We're always going to generally have one dependent variable for our analyses. But we have one independent variable that we want to look at. So let's go back to our original question about whether or not weight impacts the price of a vehicle. So to do a regression Stata, it's very easy. We just have the terminology, the command that tells Stata what we want to do, regress. The first variable we always put in just about any statistical command for Stata is going to be the dependent variable. So in this case, we want to model price, and we want to look to see what is impacting price, for example. Every variable that follows that is Stata knows as an independent variable or perhaps a controlling variable that we're also going to control for, right? So this is it. This is the simplistic, sort of command interface in order to do a regression. Now, a number of things that we get whenever we go about the process of doing this regression, right? So first we get a standard ANOVA table. We won't go too much into this because this is, I mean, it's just like a regular ANOVA table, but we really want to focus on a couple of things over here. One, our number of observations. This will give you your overall N for your analysis. Second, we want to look to see these two things, this F and this p-value that's right here, the probability greater than F. Now, what this allows us to do, this F statistic allows us to see ultimately, does our model as a whole fit our data well, right? And so what we're testing essentially is we are utilizing this statistic that we call the R squared. And so the R squared tells us the amount of variation in our price, right? We've got lots of different prices, $10,000 and 20 and 30 and so on and so forth. How much of that sort of variation in that price can we predict using weight? And so think of it as a big giant pie. We've got 100% of variation that's out there, all these different prices. We're saying based on this is the percentage for our R squared. We're saying that we can explain about 29% of that 100% in our variation in our price. We can explain about 29% using a car's weight. So not too terribly bad. There's no real good or bad R squared. You would think, oh, well, shouldn't you be close to 100%? It's very hard to get close to 100%. So, it depends on the field that you're in. Anything generally above 10% is considered to be pretty good in the social sciences world. So this is not too terribly bad, right? I mean, we've got a good 30% that we're explaining with just one variable, mind you. Now, the question is, this is in our sample. We're explaining 29% of the variation of our price using weight in our sample. Could we expect to explain at least some element of price in our population, whatever our population, maybe it's all vehicles, this might have been a sample of vehicles as well. So this is what our F statistic and our p-value allow us to see. Allows us to see in the population, would we expect that if we modeled a regression with price and weight for a whole population, would we expect to see an R squared that was significantly greater than 0? And again, we're using the statistically significant terminology because we're saying, would we expect to explain at least some part of the variation in our population? And so we get an F statistic because of that, which is driven by this ANOVA table, and we get a p-value. The p-value reads like every other p-value that we would do. Typically, if we're using an alpha of 0.05, right, we would be comparing this to 0.05. If it's less than 0.05, in this case, we would say that it's statistically significant. So yes, we are seeing that it's very likely that our R squared in our population of this sort of relationship would be greater than 0. And if it's greater than 0.05, which it's not in this case, but if it were greater than 0.05, we would say, no, there does not appear to be a statistically significant relationship, all right? So these are some of the pieces of the overall model fit. And what I like to usually tell my students is, look at this first. If this is non-significant, you really don't have to bother with going down here and trying to interpret the coefficients, because if your model is non-significant, then generally your coefficients are going to be non-significant, or they're going to be so meaningless that it's not really useful to interpret it as part of it, right? So since our model is significant, we're going to continue forward, and we notice that here's our dependent variable listed in the top left, and then we have our only and first independent variable. We get a number of information that's here, one of which is our coefficient, and this is our slope coefficient. So ultimately, this tells us the relationship of weight and price. And what I like to do is I like to use boilerplate language for this until you really get used to the terminology. So, you can have for a 1 unit increase in X, there is a, we'll put coefficient in brackets here, unit increase in Y on average. Oops. Now, I like to use this because you can use this for almost any terminology using stata, right? Or using any sort of, so we can actually say for a 1 unit increase in X, well, what's our X? Our X is our weight. We could put that in here. We could put in our coefficient, say we want to do it 2 significant digits, so 2.04 unit increase in, what's our dependent variable? Price on average. Now, in this case, price, I think, is in thousands. So it's essentially saying a 1 unit increase in weight, however weight is being measured. Maybe it's not in thousands. I think it's actually in the units of it actually is in the units of the outcome. So we're saying for each 1 pound weight increase in weight, there's a $2.04 increase in price on average, right? And so, a 1 unit increase, a 1 pound increase in weight, when we're talking about cars, is not super meaningful. Maybe we want to interpret this as, perhaps a 10 unit increase or a 100 unit increase. And we can always just take that, right? If we wanted to say for a 100 unit increase in a weight, so for every 100 additional pounds, and you can put 100 pound increase if you want to. I just like to use the unit terminology because it's something universal as you're getting used to this. But for a 100 pound increase in weight, we take this coefficient and multiply it times 100. So we would say a 204 unit, in this case, dollar increase in price. 1,000 would be a $2,000 increase, et cetera, on average. But this is the basic terminology. Now, the question is, this is what we're seeing in in our sample. We're seeing this sort of increase. Would we expect to see at least a similar relationship in our population? And for that, again, like every other statistical method, we're going to use our p-value and our statistical significance that's there, right? So ultimately, we're seeing that this is, again, we use the same, if this is less than 0.05, it's statistically significant. If it's greater than 0.05, it's not. So the same sort of terminology that's here, the same sort of rationalization, and we see that this is statistically significant. So ultimately, we believe that there would be a relationship between weight and price in the population from there. Now, what if we want to add in some other variables? Weight's maybe just one thing, but maybe we want to add in some other elements. Well, maybe I believe that, for example, weight and miles per gallon both impact price. Or perhaps I want to look and see, like, does weight still help to explain price after we control for miles per gallon? So to do that, again, we're just going to do regress. price and weight, just like we had in the previous one. But now we're going to add another independent variable, in this case, MPG, which is our miles per gallon. Now, what we see here is we still have a relationship here. So let's look over in our top right-hand corner. We can see that we're explaining 29.34% of our variation. So this didn't go up much, right? It went up just a little bit, but it's still statistically significant, right? So we would say that our model overall is still a good fit. So let's start interpreting our coefficients. Well, our weight, this sort of coefficient went down a little bit, right? I mean, we still have a relationship, but ultimately it's a little bit less than it was before. And so from there we have 1.74. So we would say, for every 1 unit increase in X, there is a 1.75, if we're rounding, unit increase in our price or our Y, right? Again, we're looking at our p-value. This is less than 0.05. So again, statistically significant relationship between weight and price. So let's look at miles per gallon now. MPG, a 1 unit increase in miles per gallon, is associated with a 49.5 unit decrease, right? So we've got our negative sign here. So it's saying as miles per gallon goes up, the price actually decreases, right? Now, this is based on our sample. We're seeing this decrease. Here, our p-value is 0.567. So this is greater than 0.05. So this is actually not a statistically significant relationship, right? And what does that mean? Well, it means we're seeing this in our sample, but we really can't conclude that our beta, let's call this our beta 2, for example, is significantly different from 0 in our population. So we're saying 0 is a plausible value. And if you are sort of familiar with confidence intervals, you can see this is the range of potential values that this could be in this population. This coefficient could be in the population. We have anywhere from -221 to +122. So in that range between here is 0. So it's saying there's a possibility that the relationship in the population between miles per gallon and price could be 0. We can't rule that out. So therefore, it's not statistically significant, right? And we would say that there's not a relationship or a significant relationship between miles per gallon and price. So those are kind of the core elements of regression. Now, lots of other potential things that we could do, which include checking assumptions, and we should always, plan to do that. There are a number of things that we can do for those, which are kind of, again, a little bit beyond the scope. This is just sort of an introduction to regression, but ultimately looking to see, like what our assumptions are and whether or not we meet our assumptions and sort of the next steps. But this was just a quick introduction to our understanding of regression and how to utilize regression using Stata. Again, we can go beyond the scope of this and we can ultimately go into logistic regression and some of the other forms. But this should give you at least an initial sort of examination into this and how you utilize this in Stata. And I encourage you to play around with it. I mean, there's nothing you can ever break in Stata. So, I encourage you to play around with it, play around with the ideas, play around with the idea of how to interpret the coefficients. And I've given you some boilerplate. Note that you will see lots of different forms of language. Some people like to say there's an association, right, or a relationship, or they like to use some of that terminology. So every 1 unit increase is associated with a blank unit increase in our Y variable. So there are lots of different ways to do that. There are no really perfect, like ideal way. These are just ways in which people sort of utilize these elements. So I hope you've enjoyed this video. I hope this has been useful. Hopefully, if you've got additional questions and things like that, I encourage John is more than welcome to share my information where you can reach out, particularly if you're planning on doing a regression for a dissertation or a thesis. It's really helpful to kind of go beyond this and feel really comfortable with these ideas. But hopefully this gets you started in that direction. So thank you all for your time and have a wonderful day.